Hello guys, welcome to our talk. We're going to talk about DroneCI, and we want to take you on our journey, the journey of the last half of a year of introducing a container-based CI system into ownCloud as a company, some of the challenges we faced, some of the issues we had, and the whole learning process we had during the time. Who of you has heard about DroneCI? Not just because of the talk before. Okay, so there's quite a few people. That's nice. So it's DroneCI people. We take that into account. Let's quickly talk about us. I'm the guy on the right. I'm a minor drone contributor. Mostly he's doing the heavy lifting, also with the plugins. I actually love Python, but now I work for a company that does PHP. I don't know how that happened, but that's how life goes. I'm very much a clean code advocate, and most of my things are rooted into the DevOps sector. And at ownCloud, I take the lead of a solution architect, the role of a solution architect, and as a QA lead, bringing in back feedback from the customers into our product, into the CI pipelines all around.
So my name is Boerger. I'm a long-time drone contributor. I'm also managing the drone plugin namespace. I'm a gopher, and I love automation. And I'm working also for ownCloud as a DevOps engineer. I'm the guy who started to introduce drone at the ownCloud project.
Cool. Who of you knows ownCloud? Okay, then let's quickly talk about it. At the core, it's a file sync and share platform. So you do whatever you do on your computer, and then you sync it to your own database servers. It's all owned by you. And then you can share it with people in your company, with your colleagues, with friends, and they can contribute and work on it. Basically, that's the promise of open collaboration as an open source platform. So it's not vendor locked in like the big G or any other, or the big D, Dropbox or anything like that. So that's basically the promise of it. What's more interesting for our talk is looking at the tech stack. ownCloud itself is a web application, so it runs on PHP, Apache as the backend, JavaScript, CSS, all the fancy stuff in the front end. And we kind of got ourselves into becoming a distributed systems because we're dealing also with databases, with caching mechanisms like Redis. We have authentication and user management that's also not inbuilt, or can be inbuilt, but we also talk to LDAP, AD, so we also need to talk to those systems, depending on whatever you want to do. If you want to do full text search, you also have Elasticsearch in the backend. So we kind of become the central hub to being a distributed, or with distributed systems, and that's also some of the challenges we face during development and testing. The project itself is open source. We're working on GitHub as a platform. It has a core repository, and we have about 80 other repositories that interact with the code that's in the core repository. So it's we've divided our work, but it also means for our workflow, any changes in the core has effect on all of those 80 other repositories. That's something that's very important to manage.
So I will talk a little bit about where we started at all. I think most of the tools are pretty common or used by many organizations. The old infrastructure had been based on one side, Travis CI, where we were running our dev-based tests like Litmus, CardDev, CalDev. We did the PHP test syntax checks, and since mid of 2017, we were also running Selenium tests on that. Beside that, we had multiple Jenkins instances, some public available, some private instances, where we were running unit tests with different PHP versions and also different database versions. Different storage providers like Swift, Ceph, Samba. We had an integration test suite. We were automatically testing upgrades from release to release. And we also had Smashbox tests, which had been mostly testing the desktop to server sync protocol. We had various pain points, especially with Travis. The CI environment have not been really reproducible. The developers just said, it works for me, but Travis has shown that it's not for Travis the case. That's something we really disliked. Beside that, we had quite often timeouts for the test suits on Travis, because there had been far too much or so complicated test suits, so that Travis just said, that's it. Because of all the number of repositories and the limited queue at Travis, sometimes we had to wait for days until we got the results on pull requests or also on pushes. And you don't have a real plugin system, or it's not really extensible. We also tried to get more build power from Travis, and we wanted to pay for that, but it's not possible for the open source version. It's only possible for private paid repositories. The pain with Jenkins had been pretty different. For some instances that had been historically grown and which have not been set up by us, that they had been set up manually. We have not been easily able to upgrade these instances because it had been destroyed all the job configurations. And we didn't like that everything had been managed via the web UI. It has not been reproducible on different environments and so on. Also, the secrets are managed via the web UI, or you're just building some hacky script to set the secrets via the API. On the old systems, we also run quite often out of disk space. Maybe that should be resolved with a bigger machine, but that was out of scope at that time. Especially if you get into the direction of containers, for at least the jobs we have defined, it has not been cleaning up the containers correctly. That's one of the things why we ran out of space quite often. And also the services or containers required a lot of bash magic because Jenkins is not really directly made for Docker payloads or container payloads. There we had results within hours. At least it had been better than Travis, but it was still too slow for our feeling. And another pain point was the static number of executors. So that was another big limitation for our use case. But then we tried to leave the dark ages.
For a second, think about that. Our daily business was waking up, we have an internal chat, and then some developer were complaining, can someone please clean up Jenkins again because it's full, disk is full, and all our builds are failing. And it was a mess. The other day we came to work, or we come back from lunch, and then someone was saying, oh, Travis had an outage. We cannot release tomorrow because our build queue is so huge. We have to cancel jobs, or we have to wait. What are we going to do? So it was kind of really frustrating. At that time, I was also trying to assist some of the developers, do some heavy lifting. And it was frustrating for me because it felt kind of I've been every day yelled at, and it wasn't fun. Let's put it that way. And our developers weren't having fun. They just blamed, oh, we cannot work because the CI doesn't work. But then both of us, we've known Drone for quite a long time. Whom of you does like some new Drone, right? Who knows this logo of Drone? Only two. So that is basically one of the. There was 4 or 5 years back a hosted version of Drone. It was in 0.2. And that was also some of the times where I got introduced to drone. And we kind of said to people in our company, we want to introduce drone to you. It's great. It will solve a lot of our issues. And if you look at the logo, some of them felt more like this. So it's kind of the war of the worlds is going to start. And most developers weren't even appreciating the work and effort we're putting in. They were just seeing, hey, it's another system coming, and, well, it wasn't very nice. Some more things about drone. So drone itself has the premise of being container native. So anything that runs on drone is a container. It is built as a static Go binary, linked Go binary, so it's very small, and it's also just a container. So you can Docker pull drone, and you get up and running. With the promise of containers, everything was becoming of an isolated build. In the Jenkins world, the workspaces were kind of connected, the cleanup, the system, everything was virtual machines, but not isolated itself. What is also really cool, Drone had the promise that their Jenkins pipeline, like the Jenkins file, but Drone itself was solely able to be defined by the YAML configuration. So you have one YAML file you put into your GitHub repository. It's also does inversion control, so you can see also the changes. Developers can push changes to the flow of the pipeline. So it's all at one place. And another good thing about it, it's a subset or superset of the Docker Compose YAML, so people would feel at home when they're working with Docker. It integrates with several VCS providers, so it's not only GitHub, it's GitLab, it's Git, there's a couple of them. It has a rich set of official plugins, so if you want to push some load to AWS, you can do that. If you want to publish your Hugo blog, there's a Hugo plugin. So there's a lot of extensibility. And in the end, any container can be treated as a plugin. So it doesn't matter in what language you write your plugins or what you need. You can just write the plugin, put it in a container, and Drone would run it for you. And finally, something that is also, while developing or pushing your pipeline very helpful, is you can run all of these things locally on your machine, and it will execute the same containers as it would on the CI, so also developers could execute the flow online. As a basis, it kind of looks like this. You have a Git event coming in, the server schedules the build, and some agent comes to the server and says, hey, I want to have a build, I'm going to start it. It bootstraps a workspace, which is a Docker volume, and you bootstrap services as in a Docker Compose file, so you have your database, your Redis, whatever you need. And every step is then executed with all of these other, with the volume and the services available. So your cloning step is done in a container, your whatever build step is done in a container, your publish step is done in a container, so it's all self-contained. So how did we move then to Drone? Quite easily, we just installed it, but one of our main premises was going the DevOps way. We want to have it in code, so it was deployed via Ansible to some of our machines. We then started building custom Docker images, because the PHP images that were available didn't have Oracle as database client inside, and we are testing against Oracle. That's one of our requirements. So whatever your requirements for testing are, you can build your own container and have it as defined stack, which you can test, and you can also give this container to your developers where they can test with. We started a gradual migration of our main repository. We started with a very simple pipeline, fetching the code, running PHP lint check. Then we learned how our application works in these containers and put more and more load on it. We migrated unit testing, integration testing, API testing, UI testing, and up until the point where we then had a very good pipeline for our main workflow, and then we expanded it to all the other apps, we call them, the other repositories. That was quite a lot of the heavy lifting in the beginning. Taking a recap, we had a couple of pain points, and in the beginning, it was with all those Jenkins instances, it was a lot of systems to maintain. But actually what we did, we introduced just another system to be maintained. It was at least in code, but to be very honest, intermediately, we put ourselves through more strain having to maintain another system. The secrets management, Drone has a very nice API, so you can also write an Ansible script or code it, or you have a UI for management, so that was a huge improvement. And while Jenkins ran out of disk space, Drone ran out of default networks, because apparently Docker is sometimes not very good at cleaning up after itself as a daemon. That was one of the limitations we had with long-running single-instance CI systems. And some of the other things improved. So with the container-native approach, we didn't need any bash magic. Containers would provide an environment that's locally the same as remotely, executed for the CI flow. And we've become very extensible, so anything could be a plugin. So we wrote also a plugin to be able to test own applications against a specific version of ownCloud. So you could develop your own app. It has an independent version, and it can be compliant to any version of ownCloud, and you're now able to just say, hey, I want to test this app against ownCloud 10, against ownCloud 10.1. That was just a plugin, so developers just needed to include 5 lines of YAML code, and they could test their own application towards some of our main code, which was also very nifty. So intermediately, this was also a big step up, but we weren't yet satisfied with the approach.
So finally, we went into a much better direction. I mean, we still had a lot of limitations, lesser limitations than with Travis and Jenkins, but we still had the issue with the fixed amount of executors for our builds. But on our final infrastructure, we had been getting rid of Travis and Jenkins entirely. We started to scale our drone agents on demand to get rid of this limitation for the executors. The number of test suites is still increasing. We're adding more and more UI tests, integration tests, and so on. And the new infrastructure had been entirely version controlled. It had been done via Terraform and Ansible. It had been deployed to Hetzner Cloud. And we introduced the Drone Autoscaler. The Drone Autoscaler is a pretty new project, also introduced by Brad, the author of Drone. At this time, it only supported some cloud providers. There we got another image for the architecture of it. It's comparable to the previous one, except that the autoscaler is a separate service that communicates to the server and launches new agents on demand via some cloud init configuration on the configured cloud provider. Currently, it supports AWS, DigitalOcean, Google, and Hetzner Cloud. We provided the Hetzner Cloud implementation because this is simply the provider of our choice. There is also a support plan for Azure, Packet.NET, and Scaleway, or for some, there are already open pull requests. As I said, it's a simple separate service that is connected to the drone server. It's also hooked into the drone CLI. So if you want to launch the agents manually instead of directly let it automatically scale up and down, you can also just execute drone server create, and it will launch immediately a new agent on the configured provider. It checks the drone queue in a loop. And as I said, it's launching servers based on a default cloud init configuration. You can also override it, like we did it for some specific configurations, like initializing some OpenVPN client and stuff like that. And the autoscaler connects to the starts the drone agent via a remote Docker connection. And if there are no jobs available anymore, it's also unregistering the drone agent from the server. And when the agent is stopped, it's also destroying the server instance. Here you can see some build time numbers we had with since we introduced drone. So the blue line is the accumulated runtime overall, and the red line is the real build time we had on drone, and the yellow line is the build time to finish, including the waiting time within the queue. So we had a massive increase on the overall build time, up to something like 30,000 minutes per build, but the wait time...
Seconds.
Seconds per build, but the wait time had been in the range of, I can't remember, what was it in the average, the build time? 30 minutes?
It's less than that, so it highly depends on the amount. But generally speaking, on every core pull request or every core push, it starts about 9 hours of build time. Just the whole, when you accumulate that time, it's 9 hours. You get the feedback within mostly 25 to 30 minutes, because the longest job takes that amount of time. And usually jobs are in queued between 0 to 10, 15 minutes. So at most, you have to wait 45 minutes, depending on the load, what's already there. But we have infinite scale depending on the amount of service the cloud provider could basically give us or throw at us. So the one thing, when you look at the picture, the red line is the line really that takes for the job to finish, for the developer to see a result. So it's almost staying the same. Well, when you look at the blue line, it's nearly also become exponential. The more jobs we moved over, the more things we moved over from other CI systems, it gradually grew, while we still were able to provide feedback in a reasonable amount of time with the current setup. And it's not the finish yet, we're still improving, but we just got those metrics 2 days ago, and we were just like, wow, we had this feeling all along, but this proves it that the whole effort we put inside was a huge success. I'm amazed also all the time looking at that.
Yeah, and there you can also see some Grafana stats about the number of agents. We are monitoring all of that. Currently, we've got a limitation of up to 50 agents that can be launched by the autoscaler. And you can always see how the number of agents decreases within over the weekend, and directly increases with the number of new builds coming in. Something to add from you?
No.
So, evolution of our CI.
That's the fine thing. Before I want to really talk about where we're going to head next, as said before, I'm amazed by the time we managed. I cannot count a single day now where developers shouted at us anymore. It's a great feeling to wake up to your chat, to your everyday work, and it just works. And the funny thing is, no one notices that it just works, because it just works. That's really the thing. Was having a chat, I think, I don't know if it was with you or with another colleague. It's like, hey, remember the times where we've been shouted at every day? That's so far away. It's sometimes crazy how things evolve. Drone has some limitations. Right now, we kind of use a hack to schedule nightly builds. You can re-trigger a build on the last successful build, and we're doing that via the API to have kind of nightly drone jobs. We're working together with Brad, the other of Drone, to have this natively integrated into Drone. We're looking also into expanding that we could provide feedback on several parts of the pipeline. So if you have your unit tests, they're going to be a separate bullet point in GitHub saying your unit test passed, your integration test passed, your UI test passed. It's kind of nice things or achievements. We're kind of looking also to have downstream cross-repository checks. As said, right now, this is also a hack we kind of use to solve it, but we want to move forward with integrating it natively, and we're also working together with the author, with Brad, and we're looking for native Windows agent support and native OS X support to also move some of our clients. So ownCloud provides a desktop sync client. So it synchronizes your files from your desktop to the cloud. And we currently use different providers to build it on there because Drone cannot do that natively right now. Oh, it's going to do that soon. What's also important for us is archiving the build data, because within the half a year, we accumulated about 200 gigabytes just of build logs that are not properly looked at again. Maybe, we don't know. We just need a way of archiving that that's not currently seen. And I already mentioned the triggers. I want to go into a final recap and lessons learned, something that wasn't not clear from the slides maybe, but something we realized afterward, or maybe the slide of the War of the World showed it. Just because you want to introduce your favorite CI solution into your company doesn't mean it's going to be a success. We had a lot of pushback from the teams. They just complained, oh, it's just a fancy UI for another failing system. In the end, they didn't realize that this failing system now became stable and everything is working and they don't have to worry about, because they can focus now on their actual tasks. So also be prepared that no one will praise you and say, hey, you're the cool DevOps guy. But I think the most important part is that you have to continuously work together with the teams, introduce the tool to them, hold their hands a bit for a while so they accept it, and you can move forward. Makes your life very much easier. Yeah, the thing is, everything works great until you move to production. We had a couple of test pipelines set up, and we threw a lot of load at them. I thought, hey, it's great. And then your developers come along, and they just push ridiculous amounts of pull requests and whatnot. At some point, we introduced a new dependency management bot that would create pull requests. And the day it was introduced, it created about 100 pull requests across all of our repositories. So just threw 100 jobs at the CI system, and it didn't like it at that very point of time.
You can see it at the spike, the green spike that had been the depender bot that opened, I think, something like 100 pull requests.
So we also learned it's not just your real software that is great, that has to be cared about when you're moving into production. Also your CI system, when you move it to production and you put real load on it, it can explode in your face. And I've become more and more an advocate of having smaller infrastructure. We had initially our Jenkins was a machine with how many cores? 64?
It was a machine with I think 32 cores and 128 gigabytes of RAM. And yeah, it had been killed regularly. So
it had kernel panic faults, and we needed to manually reset it in between. So it's also you have to keep in mind when you do massive loads on things, especially also with containers, they all share the same kernel, and the kernel is ideally perfectly namespaced, and all the resources are namespaced, but they're not. So for running a CI system and scaling it massively, I'd rather have the infrastructure provider take care of the separation, and we just threw another, like we rather scale out than scale up for CI systems, because the scaling out gives you a lot more parallel performance than scaling it up, at least in our case. I think that was basically it from our side. Saying thank you for letting us share that. I hope some of those of this journey helps you to have a journey in your company for whatever you're going to do. If you have any questions, feel free to ask. Yep.
Do you consider other hosted solutions other than
Yes, we did. We looked at them.
Question.
Sorry, because we didn't have that box. The question was if we have considered other hosted solutions compared to Travis. Yes, we did. But in the end, you always, the amount what we needed of build power at the very same time was not sufficient with the pricing we would pay. And also the extensibility for us wasn't given. So with this PHP application, testing it sometimes requires to jump through hoops, and it's not always easy the way our software is built. Let's put it that way. So And additionally, having it on our site, and it's open source, we're an open source company, we love open source, we want to contribute back to open source. Just going to a service that's managed for us was also at some point not favorable for the whole team. It's also a mindset that we would rather use open source and do it in our company to work together.
Other questions? Why the autoscaler is limited to 50 agents? This is just a current number we have decided to get some cap for the monthly costs of the CI system. Initially, we started with a limitation of 20 agents, but that had been, especially in the working hours, not been enough build power. So we increased to 50, and currently it looks good so far. But yeah, I mean, if we need more build power, we can increase it how far we get resources from the cloud provider. This is just a limitation we have set for us.
Yeah, can you tell us something about the cost savings on these build processes when you compare DroneCI pipelines with Jenkins CI?
So the question was if we can say something about the cost savings with Jenkins and Drone. I can tell you that with running 50 agents with our cloud provider, we will have a maximum cost of about 250 euros per month for having 50 parallel compute resources you can just use. I'm not quite sure what that single instance machine costed.
It was a little bit more than 200 euros.
Yeah, and then we had 2 or 3 other. So it's roughly amount the same of money we spent, but the velocity we gained and the flexibility we gained, that out benefits, even if the other system would have been cheaper in the end. If you compare it to cloud-hosted solutions for 250 euros, you don't get very far, which is also something to the other question back. Yeah.
What? Sorry, what? The system, how many developers are using this system? At ownCloud, do you have the number of the developers?
It's roughly 12 developers in-house, but we're working with a lot of collaborators from an open source community. So I don't have an exact number, but 12 collaborators that push on a daily basis. But from the community, there's also more input that's coming. Yeah. Oh.
One important aspect is when running CI in the cloud is high availability. So, I mean, in that architecture picture, there was always just one master node. So if this one fails, is Drone available? How long does it take that it is available again? What have you done in this direction?
So the question was, since you can see only one master, what happens if the master fails? Currently, Drone doesn't have a real HA mode integrated. It's planned for some soonish upcoming release. There have been already some work done to outsource the build queue into especially for public cloud providers like the pub subsystems, to make it possible to have it highly available. Currently, it's not, but yeah, it's some feature that will be worked on upstream. This is so far the only limitation we got. Yeah. Yeah, but currently the drone server had been, I think, the most stable part of our entire stack.
We got room for one more final question. Yeah.
Yeah, you mentioned that using drone and the autoscaler was your start of the golden age of Series E.
Yeah.
So what's next? What are your next improvements you're focusing on?
Coming back to a bit of the slide, but generally, besides improving drone with the kind of integrated trigger functionality, we're also wanting to improve our pipeline further to save a lot of those build power, which right now is wasted CO2. So some of the suits still run inherently of the way drone schedules jobs. We have a parallelization of 45 jobs, which are at the same time scheduled at 45 jobs. We don't have a proper fan out, fan in system yet. Working with Brad on it to furthermore have a fan in, fan out, so you have a preliminary check if some stuff like your code bases at least fits a coding style, and you then just fan out for the other tests if some conditions are met. That's one of the steps. But other than that, we don't have huge aspirations. It's already becoming great.
I would say we are pretty happy with this stack like it is now. I mean, there are improvements we would like to tackle, but they really don't have such a high priority because everything is really running great so far.
Great. I think that's it from our side, just in time. If you have any other questions afterward, just come and talk to us. Also, if you have multi-arc questions, he's the guy. He's pretty much about that. Thank you, guys.
Thank you.